All right, welcome to the next video in section 4.4. First of all, sorry about the end of the last video. We had some technical difficulties. Apparently, it was recording just fine, but my screen controls all froze up. I'm going to try to cut out that last little bit, so you may be thinking, well, I don't know what he's talking about. There you go. You were lucky if you don't know what I'm talking about because you didn't have to watch me flail through the last 45 seconds of the video. I did say I was going to. I talked very briefly about feature of the calculator that's useful when you're doing advanced calculations. If you look down here on this calculator, you'll see the STO, which is the store button. And the way this works, and the reason it's nice, is if you have a complex calculation and you've come up with some answer, it's accurate to however many decimal places your calculator can hold, which is significant. You don't want to round off at each step of the problem because every time you round off, your next step gets a little less accurate. It doesn't really matter when you're in algebra, geometry, algebra 2, but as we get more advanced, this can make a significant difference. So here's how it works. You type in a number or you calculate a number. You hit the store button, it will put a little arrow next to your number. You can see that arrow right there. You choose a variable using your alpha keys. In this case, I chose A. So 25 has been stored in register A. When I need that number, I can just type A, or I can use the recall, which is right above store, to recall, and it will pull the whole number out. So in the last problem, I had calculated T, and when I calculated T, it gave me a very long number. And then the next part of my problem was y equals, I believe it was 2 to the T minus 3. Well, I could type in 2 to the power of, well, actually, I could just so A minus 3. And the advantage is that I will get many more decimals of accuracy. And then when it gives me my y value, I can round that off to my 3 decimal places or whatever it is that I want. All right, hope that helps. I'm going to go ahead and clear that. And today's topic is the derivative of natural log of x. And we know that y is equal to natural log of x. Now we could use definition of derivative. The derivative is equal to the limit as h goes to 0 of natural log of x plus h minus natural log of x, all divided by h. The problem is we don't really have any way to do anything with that. We don't have an expansion, so it doesn't really help us very much. So what we're going to do instead is we're going to rewrite this equation over here, and we're going to use implicit differentiation because we know that e to the power of y is equal to e to the power of natural log of x, but e and natural log are inverse operations, so e to the y equals x. And now if I take the derivative of both sides, I can use implicit differentiation where y is my inner function and e is my outer function. So I appear to have switched colors here, but there it is. So let's take this derivative. Well, the derivative of the outer is itself times the derivative of the inner is equal to the derivative of x, which is 1, which means that the derivative of y with respect to x is 1 over e to the y, but e to the y is just x. So this is equal to 1 over x. The derivative with respect to x of natural log of x is in fact 1 over x. All right, let's do an example. We'll switch to the next page. This will be example 3. And if you're following along in the book, these are straight out of the book. We have a line of slope m passes through the point 0, 0, and it is tangent 2y equals natural log of x, find the slope. So what do we know? Let's draw a sketch. There's y equals natural log of x. I have a point that passes through 0, 0 and is tangent to the graph of natural log of x. Let's say that it is tangent at a, comma, log of a. Natural log of a, excuse me. So what do I know about the slope? Well, I know that the slope is equal to y prime, which means that the slope is equal to 1 over x. I also know that the slope of that little line segment is equal to natural log of a minus 0 divided by a minus 0. And since I'm dealing with the point a natural log of a, I know that this is equal to 1 over a. So natural log of a over a must be equal to 1 over a. Well, this implies that natural log of a must be equal to 1. Excuse me, which of course implies that a must be equal to e to the 1, which is just e. So the slope of that line, the slope of that tangent, is equal to, be careful, 1 over a. All right, why don't you go ahead and do exercise, exercise 31 in the book, and we'll be back with the next video. Thanks for watching.